Assalamualaikum and good day to our lecturer, Puan Rosalbia. And today we would like to present our mini project for MEC435 Computer Aided Design with title Multifunctional Wheelchair. So this project focuses on improving the conventional wheelchair by integrating a multifunction. Throughout this project, we apply CAD, which is CATIA, knowledge to design a wheelchair that is more practical and user-friendly. So in this presentation, we will explain overall about our mini project. And so for the introduction, in recent years, mobility aids such as wheelchairs have become increasingly important in improving the quality of life for people with disabilities, elderly, and the individual recovering from injuries. So these devices are no longer used only for transportation, but also help to promote independence, comfort, and participation in daily activities. However, most conventional wheelchairs are designed mainly for flat and indoor surface, making it difficult for users to navigate uneven ground, slope, curve, and stairs. So this limitation reduces accessibility and increase the reliance on external assistance, highlighting the need for an improved mobility solution. So the objective of this mini projects are: first, design a multifunctional stair climbing wheelchair using CATIA that can operate on stairs and uneven surface. Second, to develop a basic control system using a controller and toggle switch for its functionalities. Third, to incorporate a lifting mechanism that allow the wheelchair to function as a trolley for carrying load.
Traditional chairs are initially present to flat pavement. Our proposed design to tackle stairs and all terrain. Plus, those small front wheel on the standard chairs are huge safety risks. They can catch on every lips and crack in the sidewalk. In our design, we use a larger and more stable wheelbase to negotiate that. I would like to highlighting that we use ergonomic to fix height is such as limitation to a user trying to reach counter or interact eye-to-eye level with another person. The adjustable height in our design is just nice to have. It also a dignity and independent features. And as you can see, traditional wheelchair only limited usage to flat or even surface. Our design can use for stair climbing and all terrain capables. Not to mention that traditional wheelchair have a small wheel and it also causes risk for getting stuck in the road. And our design, we enhance stability for even ground. And not to mention that traditional wheelchair don't have storage, and our is we insert the storage at the wheelchair. And our main advantage is we can adjust the height of the wheelchair. This is our pure chart. As you can see, we benchmarking 3 design against our standard electrical wheelchair, which is we use as our datum. The criteria we use for benchmarking is safety, comfort, durability, ease of use, maintenance, caregiver effort reduction, and affordable. And as you can see, the lowest rate for this pure chart is design 1, which is 7. The middle is 12, design 2, and the highest is our design proposal, which is 14. And as you can see, design 3, which is our design proposal, is called the highest among the 3 design, and it also shows that our design is the best among the 3 design.
So this slide is exiting electric wheelchair. This slide shows the features of the exiting electric wheelchair. It can move on road and off-road surface, but it has a limitation of flexibility on the terrain. It cannot climb the stairs, which is restrict user mobility in non-accessibility area. This seat height is not adjustable. The seat is not folded, and it does not support wireless control. It also cannot be modified into a trolley. Overall, the exiting wheelchair provide basic mobility but lack adaptability and functionality features. So this slide is exiting electric wheelchair. This slide shows the features of the exiting electric wheelchair. It can move on road and off road surface, but it has a limitation of flexibility on the train. It cannot climb the stairs, which is restrict user mobility in non-accessibility area. The seat height is not adjustable. The seat is not folded, and it does not support wireless control. It also cannot be modified into a trolley. Overall, the exiting wheelchair provide basic mobility but lack adaptability and functionality features.
Now that we've seen the overall project scope, I'm going to walk through the components that we as a group made in Katia to build our mini project, the multifunctional wheelchair.
Those are the list of components that we design and draw individually before being assembled into the complete wheelchair. So the first one is the main structure component, which is the frame, which support the overall load and ensures stability. The rear wheels, L-seal, gear, sprocket from the mobility system allow movement on road off-road surface. The track system, which include the frame track, track roller, support arm, is designed to provide the better traction and smooth movement during climbing the stairs. Components such as the actuator and absorber help to control movement and absorb shock from user safety and comfort. So the next is for the user support. Parts like seat plate, cushion seat, backrest, armrest, footrest, and hinge were designed to improve ergonomic and adjustability of the wheelchair. The hinge mechanism allow folding and seat height adjustment. So the last one is electrical and control related component, which is include the control remote holder and the electric compartment, which is manage the wheelchair operation and power storage. So the all these components were designed and drawn by one by us to ensure proper fit, functionality, and ease of assembly before forming the final multifunctional wheelchair.
So the total parts or models that we have made is 31 parts to complete our project, the multifunctional wheelchair. So this is the first 15 parts that we have made, and this is the rest of the parts, which is the total is 31 parts to complete our mini project. This is the complete assembly model of our multifunctional wheelchair. This is the assembly drawing of the finalized multifunctional wheelchair. And lastly, this is the exploded drawing of the multifunctional wheelchair that includes the BOM table, bed of material table, that has clearly labeled the components. For the finite element analysis FEA, we have chosen the hinge of the seat to be analysis, where the part that we have analysis is the fixed part of the hinge seat, where we have applied the force to do the bending analysis. So we have chosen the fixed part of the hinge because it is a critical part to stand the weight of the applied load from the person sitting. So the material used for this part is steel with a yield strength of 2.5 times the 10⁸ millimeter square, where we have from the figure we have shown that the maximum stress is 8.39 times 10⁷, and whereas the blue color is the minimum stress, which occur at 1.46 times 10 to the power 4. So by calculating the safety factor, we have approached the safety factor of 3 at the value of 2.1. So the other part that we have done analysis is the tire of the rear wheel. Why we have chosen this is because it is a critical part for the wheel to carry the overall load of the wheelchair. Okay, the same material is used for the tire rim, which is steel. It has a thermal expansion coefficient of 1.17 times 10 to the power of -5 K and a strength of 2.5 times 10 to the power of 8. So as you can see from the figure, red is the maximum stress with a value of 2.26 times 10 to the power of 7, while the blue is the minimum stress with 1.22 times 10 to the power of 4 Nm square. So we can see that the maximum stress is less than the heat strength, and by calculating the safety factor of the rear rim, it is at approximately 11. So the tire rim structure is highly safe and capable of supporting the applied load. Lastly, for future improvements, we have discussed as a team how we want to improve the multifunctional wheelchair. And the first improvement that we want to do is to have high density lithium and solid state batteries, which is a new battery management system BMS, and higher density cells now, allowing these power heavy chairs to travel a much longer distance on a single charge and climb dozens of flights of stairs without significantly draining the battery faster. Next is social distancing mode, where it is in an AR integrated system where it maintains a social buffer, which is around the user in crowds. The wheelchair will automatically adjust the speed to match the walking convenience. So this can ease the user to not needing to push the joystick to match the other people's pace. And lastly is active airbag protection. So this highlights to address the people that have fear of tipping on steep inclines. So this testing micro airbags that deploy if the chair detects a critical loss of balance to protect the user from a fall.
So in conclusion, this mini project successfully addressed the limitation of conventional wheelchair through a systematic and research-based design approach by focusing on key performance parameters such as stability, safety, and maneuverability and user comfort. A practical and functional stair climbing wheelchair design was developed. So the project applied theoretical knowledge in mechanical design, control system, and CAD modeling using CATIA, while also enhancing a teamwork and problem-solving skill. Overall, the project made its objective and provide a strong foundation for future development and improvement.